Let us see how to convert unlike fractions to like fractions. So we know that unlike fractions are the fractions that have different denominators. So here are two examples, 1 by 2 and 3 by 4. Both of them have different denominators. Another example can be 2 by 3 and 5 by 6. Again, both of them have different denominators, right? And like fractions are the fractions that have the same denominator. So when we compare two fractions or when we add or subtract two fractions, they must be like fractions. We cannot add two unlike fractions. We can only add like fractions. So it is very important to understand how do we convert unlike fractions to like fractions. Then only we'll be able to do the operations. Right, so we'll see through an example. Say for example, we are given 2 by 3 and 5 by 6. These are unlike fractions because they have different denominators. We have to convert them to like fraction. Right. So what we need to do is we need to make their denominator the same. How do we make their denominator the same? We try to find a common multiple of 3 and 6 or whatever the denominators are. Right, so we have 3 and we have 6. So what we'll do, we'll try to make their denominators the same. In order to make the denominator the same, we have to find the common denominator. How do we find the common denominator? We find a number that is a common multiple of 3 as well as 6. So that comes in the table of 3 as well as 6. That will be the common denominator. So if you find the LCM of 3 and 6, we'll get 6. So the LCM of 3 and 6 is 6. Why? Because 6 is completely divisible by 3. So HCF of these two numbers is 3 and LCM is 6. So we calculated the LCM as 6. Now we know that 6 must be the common denominator of both these two fractions, right? So the first number I have 2 by 3. So this is the first fraction. Now I have to make its denominator 6. So I'll try to find a number that I must multiply with 3 so that I'll get 6, which is 2. So if I multiply 3 with 2, I'll get 6. So when I'm multiplying the denominator with something, I should also multiply the numerator with the same thing. Right, so 3 times 2 is 6, so I'll multiply the numerator with 2 as well so that these are equivalent fractions, right? So the value does not get changed. I multiply it with the numerator and denominator both. So I get 4 by 6, right? Similarly, 5 by 6. So it already has 6 in the denominator, so we don't have to convert. So we get 5 by 6. Right, so these were two unlike fractions. We have converted them to like fractions, which is 4 by 6 and 5 by 6. What it means, I mean, we have seen mathematically. Let's now look at it graphically. So we have 2 by 3 and 5 by 6. So this is 2 by 3 and this is 5 by 6. Right, both of them are unlike fractions, so we cannot do any operation on them. What we try to do, we try to find the LCM of 3 and 6. Right, once we calculate the LCM of 3 and 6, we get the LCM as 6. Now what we do, we divide this figure into 6 halves. So initially it had 3 halves, so we divide this figure into 6 halves. So 1, 2, 3, 4, 5, 6. So we got 6 halves. Now initially 2 of the 3 halves were shaded. Now 4 of that 6 half is shaded, because what we have done is we have divided it like this. Right, let me just do it again. So this is the first line that I have created. This is the second line, and this is the third line. So now I've divided it into 6 equal parts. So 4 out of that 6 part is shaded. So I'll get 4 by 6. And this is 5 by 6. Now we can easily compare these two numbers, or we can add these two numbers. We can subtract these two numbers. Right? Let us solve some more examples. So we have 5 by 8 and 7 by 12. Again, these are unlike fractions. We'll try to convert it to like fraction. So the denominators are 8 and 12. Right? We try to find a common denominator. So one method is we can use the listing method to find the LCM. So we'll get 8, I'm just writing the multiples, 8, then 16, then 24, then 32, then 40, and so on. For 12, we'll have 12, 24, 36, 48, and so on. Right, so the common multiples are 24, right, which is the smallest. Right, so 24 is the LCM. Right, now what I'll do, I'll try to make both their denominators as 24. So 5 by 8 is equal to, because I know the denominator is 24. right? I just have to find the numerator. So what number should I multiply 8 with so that I get 24? It is 3. So I'll multiply 5 with 3 as well, right? So 5 3s are 15. We'll get 15 by 24. So 5 by 8 is equal to 15 by 24. Now I have 7 by 12. Again 7 by 12, I know the denominator is 24. So what number should I multiply 12 with so that I get 24? It is 2. So I should multiply 7 with 2 as well. So when I multiply 7 with 2, I get 14. So the first number becomes 15 by 24 and the second number becomes 14 by 24. So we are basically writing equivalent fractions. So the value does not change. We have just changed the denominator such that these two unlike fractions becomes like. Right. Similarly, we have 5 by 24 and 7 by 36. We have to convert them to like fractions. So I have 5 by 24 and I have 7 by 36. Again, we can use the listing method to find the HCF and LCM. So we can either use listing method or the factor tree method. Both the methods are going to work. So we have to find the common denominator. So I'll just list the multiples of 24. So it is 24, 48, 72, and so on. Right, 36 it is 36 and then 72, then 108 and so on. Right, so the smallest common multiple is 72. So their LCM is 72. Right. If I want to use the factor tree, I can just build the factor tree for 24. So it is 2 times 12, then 2 times 6, and then 2 times 3. For 36, what I'll do, I'll write 2 times 18, 2 times 9, and 3 times 3. Okay, so 24 I can write as the product of primes as 2 times 2 times 2 times 3, right? And 36 I can write it as 2 times 2 times 3 times 3. Right, so this is common, this is also common, and 1 3 is also common. So the LCM will be 2 times 2 times 3. So whatever numbers are common, I'm just writing them once and then the remaining numbers times 2 times 3. So 2 2s are 4, 4 3s are 12, 12 2s are 24, 24 3s are 72. So we get the same answer. So LCM is 72. Right. Now what I'll do, I'll try to write this with denominator 72 and this fraction as well with denominator 72. So 5 by 24 is equal to, we know the new denominator. So what number should I multiply 24 so that I get 72? So we can either divide, right? So 24 3s are 72 and I should also multiply 5 with the same number. So 5 3s are 15, right? So this number gets converted to 15 by 72. Now I have 7 by 36. I know the denominator must be 72. So I'll write 72 here. So 36 2s are 72, right? I should multiply 7 with 2 as well. So I'll get 14. Right, so now 5 by 24 becomes 15 by 72, 7 by 36 becomes 14 by 72. Now they become like fractions without changing their values, right? So, I mean now as the numbers become bigger and bigger, right? Finding the LCM becomes more and more complicated, right? And more time consuming. So is there another method that is way more simple when compared to the two methods that we have discussed? One was the listing method, the other was the factor tree method, right? So there is one more faster way to find the LCM and it is very convenient, especially when we have more than two numbers to find the LCM. So till now we have just studied two numbers, we have to calculate the LCM of just two numbers. However, when we arrange fractions in ascending or descending order, or there are three unlike fractions, we have to convert them to like fraction. So we'll have to find the LCM of three numbers. In such cases, these factor tree method and listing method becomes complicated, right? So we need to have another method that is way more convenient when compared to these two methods, right? So we already know two methods to find the LCM. The first method is the listing method, the other method is the prime factorization using factor tree, right? There is one more method that we call as the division method or the cake ladder method, that is used to find the LCM of the numbers. So in this method, what we do, we write both the numbers simultaneously. For example, we had to calculate the LCM of 24 and 36, right? So we had to calculate the LCM of these two numbers. So we write them simultaneously. Now just like we used to build factor trees, right? We start by finding the smallest prime number. Say for example 2. So 2 is the smallest prime number. So I'll check whether any one of these is divisible by 2 or not. Right now, since 24 is divisible by 2 and 36 is divisible by 2 as well, so I'll just divide it. So 2 times 12 is 24 and 2 times 18 is 36. Now again I'll check with the same prime number, which is the smallest. So 2 times 6 is 12 and 2 times 9 is 18, right? Again I'll start this process again search if it is divisible by this. So now you'll notice that 6 is divisible, however 9 is not divisible. So we'll still divide, right? So even if one number is divisible by the prime number, still we are going to divide, right? So 2 times 3 is 6, and since 9 is not divisible, we'll just write that number as it is. Okay. Now we'll move on to another number because both of the numbers are not divisible by 2, right? So if any one of the numbers are divisible by a given prime number, then we divide. If they are not, if both of the numbers are not divisible, then we don't divide. Right now, for example, here we cannot divide by 2 further because none of the numbers are divisible by 2. So we move on to the next number, which is 3. Right, so 3 times 1 is 3 and 3 times 3 is 9. Right, again we get 1 here. Now this number is 3, so this is also divisible by 3. So we'll again write 3 ones. So 3 ones are 3 because 1 is not divisible by 3, and then 3 ones are 3. Right, so we'll just write 1 here as it is, and then 3 ones are 3. Now the LCM of the number is the product of all these numbers. So 2 times 2 times 2 times 3 times 3, which is 72. So the LCM of these numbers are 72. Okay. So this is the division method, also known as the cake ladder method. Right. What are the steps that we need to remember? So we start by dividing by the smallest prime number. And that smallest prime number must divide at least one of the numbers. So it need not divide both the numbers. Right? Even if one of the numbers are divisible, then also we can use that number to divide. Okay, if a number is not divisible, write it again unchanged. For example, here 9 was not divisible by 2, so we wrote it as it is, unchanged. Right? How long we need to divide? Until and unless all the numbers, or towards the end, we have 1. Right? Now see, there was one advantage of the prime factorization method. That is why we used to prefer it when compared to the listing method. The listing method worked only for LCM. For HCF, we had to list the factors. So we had to list out the multiples for LCM, we had to list out the factors for HCF. The prime factorization, the same prime factors used to work for HCF and LCM. Right, so is this quicker method also applicable to HCF? Can we also find the HCF using this method? If yes, then only this method will be effective when compared to this, right? Because this method already had an advantage that we can calculate HCF and LCM just by building the factor tree. So if this method can also help us in finding the HCF, then this will be the most powerful method, right? Even powerful than this method. Why? Because we can calculate HCF of LCM and HCF of any numbers in that case, say 3, 4, 5, 6 very quickly, right? When compared to these two methods. So it turns out that we can also find HCF using the same division method. How do we find HCF of these numbers? Now, the method is just slightly different, right? What we do, we just write the two numbers as we do for LCM. Then we find a number that is common in both two. So that is a common factor, right? When we are finding HCF, we are no longer interested in at least one. So if both the numbers are divisible by a number, then only we write it, right? For example, 2. Both 24 and 36 are divisible, so we write 2, right? And then 2 12s are 24, 2 18s are 36. Again, both these numbers are divisible by 2, so we'll write 2 here. So 2 6 are 12 and 2 9s are 18. Now you'll see that 6 is divisible by 2, but 9 is not divisible by 2. So we'll not write or not divide by 2 here. Why? Because when we are finding HCF, it means that both the numbers must have that factor, right? However, 2 is a factor of 6 but not 9, so we'll not write. Also 3 is a factor, right? So we move on to the next smallest prime number, which is 3. So 3 is a factor of 6 as well as 9, right? So 3 2s are 6 and 3 3s are 9. Now you'll notice that 2 and 3 have nothing in common other than 1. So we stop here when we are calculating HCF. For LCM, we did not stop. We had to reach till 1 and 1 for both the numbers. However, for HCF, when we find a number that has no common factor, then we stop. And what is the HCF? HCF is the product of these numbers. So 2 times 2 times 3, which is 12. So 12 is the HCF of these numbers. Okay, so for HCF, stop when there is no common prime factor left. Again, if we look at the difference between HCF and LCM, right, what we used to do in LCM, so this process is the same, 24, 36, we write both the numbers simultaneously. Then we divide by 2, so 12 and then 18, so 2, 12 and 18. Then again divide by 2, 6 and 9, and then again divide by 2, 6 and 9. Now in LCM, you'll notice that 6 and 9, right, they have nothing, they have only 6 has 2 as a factor, 9 does not have 2 as a factor, still we divide. Right, we have to keep dividing even though one number has the factor. Okay, in HCF we don't do that. In HCF we have to only divide when both the numbers have that factor. Okay, so we keep on dividing the numbers and towards the end we'll have 1, because see here 1 is not divisible by 3 and 3 is divisible by 3, so still we divide by 3 because at least one of the number must be divisible. And we stop when we have both 1 and 1 here, right? Here we stop when both the numbers have nothing in common other than 1. Right? LCM is the product of all these numbers, HCF is the product of all these numbers. Okay. So for 24 and 36, the LCM is 72 and the HCF is 12. Okay. Now we'll apply the same thing, the concept that we have studied, to convert unlike fractions into like fractions. Okay, we have another example, 7 by 18 and 5 by 12. Okay, we have to convert this to like fraction because they are unlike, they have different denominators. So the first step, find the common denominator. So the common denominator is the LCM of 18 and 12. So 18 and 12, I have it here. So what I'll do, I'll start with the smallest prime number and then divide these numbers. So 2 9s are 18 and 2 6s are 12. Then again we'll check if any of these numbers are divisible by 2. So 6 is divisible by 2. 9 is not. So when we divide, we write 9 as it is because it is not divisible. And we divide 6. So 2 times 3 is 6. Now both of them does not have 2 in common as a factor. So we move on to the next prime number, which is 3. So both the numbers are divisible by 3. So 3 3s are 9 and 3 1s are 3. Right. Again we get 3 and 1. So both these numbers, they don't have anything in common. However, 3 is divisible by 3. 3 has a common factor. So 3 1s are 3. We stop here because we get 1 at the end. So the LCM is 2 times 2 times 3 times 3, which is 2 2s are 4, 4 3s are 12, 12 3s are 36. Now the common denominator is 36. Right, so we'll write 7 by 18 is equal to, we know the denominator is 36. So we have to find a number that we should multiply 18 with so that we get 36, which is 2. So we multiply the denominator by 2. So in order to ensure that the value remains same, we multiply the numerator by 2 as well. So 7 times 2 and 18 times 2. So we get 14 by 36. Right, similarly 5 by 12, we need to have 36 in the denominator. So if I multiply 12 by 3, I'll get 36. So I'll also multiply the numerator by 3, which is 5 times 3. So I'll get 15 by 36. Now see, if we had to find the, so we have converted this to like fraction, right? If I had to calculate the HCF of these two numbers using the same method, 18 and 12. Right, so I'll write these two numbers again. Then find a number that is a common factor of both these numbers, which is 2. Right, we'll always start with the smallest prime number. So 2 9s are 18 and 2 6 are 12. Now see, both these numbers does not have 2 as a common prime factor. So we'll move on to the next prime factor, which is 3. Both these numbers are divisible by 3. So 3, 3s are 9 and 3 2s are 6. Now we have two numbers, they have nothing in common. Right? So we stop because we are calculating HCF. So HCF is 2 times 3, which is 6. Okay. Now let us solve another question. Here we have, instead of 2, we have 3 fractions and we have to convert it to like fraction. Again, the same concept we have to apply. Right? We have 6, 8 and 9. We have 3 numbers, we have to find a common denominator. So we have to find the LCM of these 3 numbers. Now see, if you use listing method or factor tree, you have to build 3 factor tree or you have to list down 3 multiples. Here you just have to use the same process, just write the numbers. So 6, 8, 9. Because we are calculating the LCM of those numbers, even though any one number is divisible, we divide. So we'll start with the smallest prime number, which is 2. So 2 3s are 6 and 2 4s are 8. 9 is not divisible, so we'll write 9 as it is. Then again, we have 4 which is divisible by 2, so we'll divide by 2 again. So 3 is not divisible, so we write 3, 2 2s are 4 and 9 is not divisible, so we write 9. Again we have 2, so 2, then 3 is not divisible, so 2 1s are 2 and 9 is not divisible. Now we have 3, 1 and 9. So 3 and 9 has 3 as a common factor. So 3 1s are 3 and 1 is not divisible, so we write 1 and 3 3s are 9. Right, so basically we are dividing at each step, right? Now we still have 3 which is divisible by 3 because we have not yet reached 1. So 3 1s are 3, 3 1s are 3, sorry, 3, 1 comes down, 1 comes down and 3 1s are 3. Right, so the LCM will be 2 times 2 times 2 times 3 times 3, which is 72. Now we know that the common denominator is 72. Right. So for this, we need to have 72 in the denominator. For this, we need to have 72 in the denominator. For this, we need to have 72 in the denominator. So what number should I multiply 6 with so that I get 72? It is 12. So because 12 6 are 72. So I should multiply the numerator with 12 as well. So this is what we are doing. 5 times 12 and 6 times 12. Okay. Next, 3 by 8. If I multiply 8 with 9, I'll get 72. Right? Which is here. So I should also multiply 3 with 9. So I'll get 27. Right? 7 by 9. If I multiply 9 with 8, I'll get 72. So I'll also multiply 7 with 8. So I'll get 56 by 72. So we have converted these 3 numbers to, or these 3 fractions to like. Okay. What if we had to calculate the HCF of these numbers? 6, 8 and 9. Right? I have 6, 8 and 9. So I've written the number. Now I just have to find a factor that is common to all 3 numbers. So we start with 2. So 6 is divisible by 2, 8 is divisible by 2, 9 is not. Then we check with 3. So 6 is divisible by 3, 8 is not, and 9 is divisible by 3. And we keep on checking. So we'll not find any number that is a common factor of all 3 numbers. Right? So the HCF is 1. Because when they have nothing in common, the only common factor that they will have is 1. So the HCF is 1. Okay. Then we have this question, convert the following unlike fractions into like fractions. Again, we have to find a common denominator of 8, 12 and 18. So we'll write all 3 numbers simultaneously. Right? Start dividing by 2 because it is the smallest prime number. So 2 4s are 8, 2 6s are 12 and 2 9s are 18. Right? Then 2 2s are 4, 2 3s are 6 and 9 is not divisible, so we'll write 9. Then we still have 2, so we'll have to get rid of this. So 2 1s are 2 and then 3 comes down and 9 comes down. Right? Then these two have 3 as a common factors. 3 1s are 3 and 3 3s are 9. We still have to get rid of this 3 so that we have 1. So we again divide by 3. So 3 1s are 1 comes down, 1 comes down and 3 1s are 3. So the LCM is 2 times 2 times 2 times 3 times 3. So again 72. Right? So we'll have 72 here, we'll have 72 here, we'll have 72 here. All 3 cases. Right? So if I multiply 8 with 9, I get 72. So I also multiply the numerator, which is 3, with 9. Right? So I'll get 27. If I multiply 12 with 6, I get 72. So I'll also multiply 5 with 6. So I get 30. If I multiply 18 with 4, I get 72. So I should also multiply 7 with 4. Because if I'm multiplying the denominator, I should also multiply the numerator. Otherwise, the value of the fraction will change. Right. So we have converted these three unlike fractions to like fractions. Right. Now, can you try to compute the HCF of these four numbers or these three numbers? Right. Try calculating the HCF of these three numbers, and this is going to be very simple. And once you are done with doing the HCF of these three numbers, try to convert these two fractions into like. So we have say 2 by 15, and then we have 7 by 35. So you have to convert these two fractions into like fraction. Okay.